We're now going to look at using StarLab with a pyroelectric sensor to measure energy per pulse of a repetitively pulsed beam. We again double-click on the StarLab icon, and we've come to the Select Devices window. This time we're going to select the pyroelectric sensor, which in this case is sensor number 2. The pulsar can have up to 4 sensors connected to it. And again, to keep things simple, we're going to select Together. We click Together and we come to the main measurement screen. As we mentioned in an earlier segment, the parameters that come up on the main measurement screen are a function of the definitions available for the different sensor types. Here's the numerical readout, which shows us the energy reading, in this case in units of millijoules. Again, we have the graphical output. And here we have the measurement parameters of the sensor that the user can choose from. In this case, we're measuring energy. A pyroelectric sensor can also measure average power. We're going to leave it on energy. Here is where the user would select the wavelength, the energy range or scale. If we were using a pyroelectric sensor that has a removable diffuser, the user would here select whether he's using diffuser in or diffuser out. In this case, that's not the situation, so that parameter is not active. The user can select the maximum pulse width. In this case, it's either 1 millisecond or 10 milliseconds. I should mention that with most of our newer pyroelectric sensors from what we call the Pyro-C line, in a number of our instruments there would be up to 5 selections offered for maximum pulse width. In this case, the instrument that we're using, the pulsar, is offering 2 selections to the user. External trigger on or off is a function that we're going to be looking at a little bit later. That's a special feature that's available using the pulsar instrument. If we were to change any of these parameters, the Save button would become active and the user would be prompted, if he so chooses, to save those selections to become the default selections programmed into that sensor. Here we have statistical information about the measurement as it's been performed up until now, the minimum and maximum energies that have been recorded, their average, the standard deviation, the number of overranges, if any, the total number of pulses counted during the course of this measurement, and the pulse frequency. The missing pulses is not active right now. That goes back to the external trigger, which is a function that's used for detecting missing pulses, among other things. And as I said, we will be looking at that in a separate video segment. Here we have the graphical display. And again, we can adjust the X or time axis and the Y or energy axis. The time axis, let's bring that down to 1 minute so that it moves a little bit more comfortably, more quickly for our purposes. The Y-axis, we can adjust using the manual sliders or by typing in a value over here. That would normally be based on the average and max and min measurements that we see in the statistics window. And we would set the appropriate scale. We have, again, various graph types. Now we're looking at a line graph. We could convert that to a bar chart, a histogram, a pulse chart, or a virtual analog needle. Different selections of graph type might be more or less relevant depending on the type of sensor being used and the type of measurement being performed. For illustration purposes, we're going to leave it for now on a line graph.